Alright, a special sitting of Cujo Maths. Let's see if I can remember anything from university. Alright, so here we've got a triangle ABC. ABC is 90 degrees, so it's a right angled triangle. We might as well mark that in. We can start having a little bit of a draw on here and see where we're going. So we're already thinking Pythagoras and trig ratios. AC is root 2, AB equals BC plus 1. So if this is BC, that length there, then this side will be BC plus 1. That's pretty ugly looking B. Let's make it look a little bit prettier. Close enough. Alright, so now I've been told we've ticked off parts A and B, and C is giving us a little bit of trouble. Find length BC and hence show that blah. Well, let's find it first. Pythagoras Theorem, that's what we've got to go with. So the square on the hypotenuse is the sum of the squares on the other two sides. So I will have the hypotenuse, root 2 squared plus, equals, getting carried away, equals, and we've got BC plus 1 squared plus BC squared. Now you can use X instead of BC if you want to. I don't want to have to redefine a variable basically, so I'm just going to go with what they gave us. That was really annoying me that it looked so bad. Let's make it look at least reasonable. Alright, so now we do our little expanding and solving and see how we go. So root 2 squared is 2. We remember how to expand these expressions. That's going to be BC squared plus 2 times BC plus 1 squared is 1 plus another BC squared. This looks like a quadratic, so let's get everything together. So I'm going to get rid of the 2 from that side. I've got a BC squared plus another BC squared, so that makes it 2 BC squared plus 2 times BC. Here I have the plus 1, but remember I'm subtracting 2 from each side, so it's going to be minus 1. We've got that far. Does it factorise nicely? Nope. So what do? Quadratic formula. BC, in this case, is going to equal negative B, so that's negative 2, plus or minus the square root, B squared, which is 2 squared, minus 4 times A is 2, and C is negative 1, divided by 2A. Make that look a little bit prettier. And we're going to have negative 2. Now, negative 2 minus the square root, obviously we can't have a negative length. So here I'm just going to make a note that we can reject the negative length, just so that we can deal with the positive. So it's negative 2 plus 4 plus 2 4s are 8. So 4 plus 8 is 12. So it's going to be root 12, which I'm going to just go out on a limb and say you can simplify to 2 root 3. Let's hope I'm not making a lot. Oh, I can't do it. Let's just make sure we know. When I get root 12, of course, perfect square, that's a factor of 12, is 4. Square root of 4 becomes 2. So that's how I got to the 2 root 3. This is all divided by 4. 2 is a common factor, so I can divide everything by 2. And I get BC is negative 1 plus root 3 divided by 2. And I think that's where you got to. And the next little bit's not so bad. Find sine A. So A is this angle up here. Sine of the angle is going to be the opposite divided by the hypotenuse. So if I take this value, negative 1 plus root 3 over 2, and divide it by root 2, that will equal sine A. So let's go ahead and do that right now. So I'm going to do... So we're still continuing on. I'm just going to go, once I can find where my cursor is, I always lose it on this thing. There we go. So I'm going to go from here. I sometimes wish it had that big yellow circle that you can see when you watch the video back. I wish it had it there as I was writing. It would make my life a little bit easier. So would being able to draw arrowheads. Alright, so here we go. The sine of A equals the opposite side, which is BC, divided by the adjacent side, which is AC. What is that in our terms? We've got negative 1 plus root 3 divided by 2 divided by AC, which is root 2. Dividing by root 2 is ugly. That's multiplied by the reciprocal, -1 plus root 3 over 2, multiplying by 1 over root 2. 1 over root 2, I'm going to have to rationalize it sometime. Let's do that now. Let's multiply the top and bottom. Remember how to rationalize a denominator. Multiply the top and bottom by root 2 over root 2. Now I'm going to work across the page here because I'm running out of room on the screen, but that's okay. So -1 plus root 3 over 2, and that's now being multiplied by root 2 over 2, and that's where we're going to have -root 2 plus root 6 over 4, and if we want to make it look nice, that's the same as root 6 take root 2 over 4. And we've got what we needed to get. Alright, that's part C. Let's go ahead and find the answer to part D. I'm going to need to do a little bit of reorganizing here. So I'm going to pause and I'll be back before you even know it. Alright, so we're back with enough room to keep going. Use a double angle formula to find sine A. You'll get an answer which looks different from the answer in C. How can you check both answers are the same? Now we have a look at what parts A and B, which I didn't go through because we already sorted those. That's great. You can see here sine 2A equals 1/2, so that's something you've already proved. So that's telling me which double angle formula I've got to use. I should be using the one for sine 2A, and of course sine of 2A is equal to 2 sine A cosine A, and although we could prove that, let's not get into that now. It's something that you'd probably be given on a formula sheet or just expected to learn, so we've got to learn it. Let's just go with it. Now I can replace sine of 2A is 1/2, so let's make that 1/2, and this is 2 sine A cosine A. So I'm going to divide by 2 cosine A. So I'm going to have 1 over 4 cosine A is equal to sine A. Great. What is cosine A? We think back to our triangle up here. We've got the cosine of A. It's BC plus 1, all divided by root 2. So BC was -1 plus root 3 over 2, and now I've got to add 1 to that. So find my cursor, 1 over 4 cosine A. So BC plus 1, so it's -1 plus root 3 over 2 plus another 1. All divided by root 2. And that's one of the ugliest expressions we'll have to deal with for a long time. Pretty ugly, but let's neaten that up first. I really don't like having this sort of arrangement here in that numerator. That's just disgusting, isn't it? So how are we going to do this? Well, we'll do the 1 over 4. Let's fix up the bit inside the bracket there. This 1 is the same as 2 over 2, so it's actually going to be -1 plus root 3 plus 2 all over 2. So that's going to make it 1 instead of -1 plus root 3 over 2. We're still dividing by root 2 at this stage. Okay, now this is sine A. Okay, very good. Let's keep going up here. That left-hand side I can fix up, but let's just get sine A on the left, because why not, while we're moving all that distance. This 4, when I multiply that numerator, is going to cancel with the 2, and I'm going to get 2 plus 2 root 3. And that's going to be over root 2, and I forgot to say 1 divided by all of that. Okay, so when we're dividing by that, we get root 2 divided by, because we're multiplying by the reciprocal now, so 1 divided by that is 1 multiplied by root 2 over 2 plus 2 root 3. And that's a good enough expression. That's a different expression to root 6 minus root 2 over 4. The last bit says, hence, oh no, how can you check without a calculator that both answers are the same? Well, we don't like irrational denominators anyway, so how about we try and, not complete the square, but rationalize this denominator, which means multiplying by the conjugate. I've just done this with my grade 10s, so no doubt you would remember all the way back to grade 10 when we did that. Let's see what we get then. I'm going to get 2 root 2 minus 2 root 6, and on the bottom I'm going to have 2 squared minus, and this is 2 root 3 squared. So 2 root 2 minus 2 root 6, well, let's put the 2 out the front, and I'm going to have root 2 take root 6. That's pretty promising, thinking back to what we had before. We had root 6 minus root 2. This could work out okay still. Denominator, 2 squared is 4. 2 root 3, when I square that, it's going to be 4 by 3 is 12. Minus 12, what's that give me? I'm going to get 2 root 2 take root 6 divided by negative 8. Well, 2 goes into that once and into that 4 times. And then this negative is really annoying, so let's multiply or divide the top and bottom by negative 1, and I'm going to get root 6 take root 2 divided by 4. So I know that that expression that I had is the right one. That equals the other one. All right, part E to go. Hence or otherwise calculate the length of the perpendicular from B to AC. Leave your answer in surd form. Wow, let's get a copy of this diagram here. Actually, it's going to be really annoying if I do it that way because it's still going to have the writing all over it, so I'm going to rub that out. And then we'll get a copy of it. And make a bit more room. This is a classic IB question, a hence or otherwise. Now, I don't know exactly how you would follow that on from what they gave us there originally, but I'm sure we'll come up with something. So hence or otherwise, calculate the length of the perpendicular from B to AC, leaving your answer in surd form. So what they're really asking is, how do I find that length? It's ugly, isn't it? So what could we do here? Well, you could find out that angle and then you could do sine, but we've got that length there, so that could work. That could work. I didn't do the first part where we actually found out how big the angles were, so whether that works or not, that might be an easy way for you to go. Does your double angle formula help with that or not? I'm not sure. What have we got an expression for? We've got an expression for sine A equals root 6 minus root 2 over 4. That's not feeling particularly inspiring. What could we do? Oh, hang on. What about if we go half AB sine C? What's that the rule for? That's right. That's the area of a triangle. So what about I went a half AB times AC, so this side by that side, times the sine of the angle in between, times the sine of A. What would that have to equal? Or what's the other way we could have this? We could have half base by height. That's another way of writing the area of a triangle, isn't it? So if I imagine the base is actually that side there, and that'll be a half by root 2 multiplied by that distance that we want. Let's just call that height h. Let's make that the thing we want. That might actually work. Because I've got an expression for AB, I've got an expression for AC, I've got an expression for sine A. Yep, I reckon we can make this work. Let's see how we can make it a bit easier on ourselves. A half and a half, let's multiply each side by 2. Bang, they're out of the way. Alright, AB. How long was AB? Oh, I've forgotten already. Let's scroll up and have a look. Oh, I think we put it in there, didn't we? Negative 1 plus root 3 over 2 plus 1, which when we neaten it up a little bit is 1 plus root 3 over 2. So here we've got is equivalent to 1 plus root 3 over 2. AC is negative 1 plus root 3 over 2, multiplied by the sine of A, which is root 6 take root 2 over 4. That's the left-hand side, and the right-hand side is just going to be root 2 times H. Not so bad. Oh, we got excited when I started writing out that left-hand side, didn't we? Because we saw 1 plus root 3 and negative 1 plus root 3, which of course is going to give me difference of 2 squares, isn't it? If you just imagine I wrote it root 3 plus 1 and root 3 minus 1, difference of 2 squares. So root 3 squared is 3 minus 1. So multiplying that top by that top is just going to give me 3 minus 1. Bottom by bottom, 2 by 2 is 4. I've still got this root 6 take root 2 divided by 4. I think we can see something that's going to happen here with this root 2 as well. Alright, 2 divided, that's 3 minus 1 is 2, 2 divided by 4 is a half. So now I'm going to have a half. So a half times this thing, I'm going to have root 6 take root 2 over 8 equals root 2 times H. Hopefully that was alright, it wasn't too quick. What did I do? I just said 3 minus 1 is 2, 2 over 4 is a half times that thing in brackets. Well, the top stays the same and the bottom 2 4s are 8. And I left the right hand side alone. Now when I divide by root 2, you'll notice this fraction on the left hand side has root 2 as a common factor. Root 3 take 1. You can see root 2 by root 3 will give me root 6, and root 3 by negative 1 gives me root 2. Yep, that's a common factor. If I just factorise that out, it's going to be much easier to see that when I divide each side by root 2, it's going to cancel. And I have an expression for the height of the triangle. Or the length of the perpendicular from AC to B, or from B to AC. So what is the length of that perpendicular? It's root 3 minus 1. All divided by 8. And that was a bit of fun, Pythagoras and trigonometry. Hopefully that all made sense. You know to send me a question if it didn't. And good to see you working hard. Hopefully you came in and picked up your diploma today. I saw a few of the guys. Otherwise, I'm sure you'll get it soon. And I'll catch you at volleyball. One more round to go. All right, Joel. Cheers, mate. Bye.